There's a large level of support. We're also adding support for more EVM-based chains right now. And it means that you can use SubQuery to analyze the same data across all these different chains very simply. And it works off the shelf of all these different chains. Now, in terms of a quick demo of how this works, I want to give you a rundown of how SubQuery works. And it's very simple building a SubQuery project. And a SubQuery project is like a recipe for how you index data from a particular chain and how you index that into a particular format. And for today's demo, I might use Optimism as an example. And let's say I have a challenge on Optimism to index or to analyze airdrop recipients on Optimism. This is a very classic data challenge of let's create and kind of calculate all the different recipients of an airdrop, who they are, the average account that was on it, and how much has been claimed, for example. So this here is a very basic example of indexing that data. And when you are creating or when you're indexing that data, there are 3 key steps around creating that index of this recipe. And I'm going to cover those today. Firstly, when you start SubQuery, you download a CLI tool and you'll initialize the project using one of our kind of boilerplate examples for all the different networks that we support. And then you'll change it. And the first file that you touch when you're building your own custom SubQuery project for your own custom use case is a GraphQL schema file. Now, the GraphQL schema file defines the end shape of your data. So let's say I'm building this airdrop app. I, of course, want to index data into a format very simply like this. I want 2 tables. I want a claims table and I want a daily claims summary. And the claims table obviously lists out all the different airdrop claims that day. And the daily claim summary is an aggregation of the information aggregated every day. So every day I can calculate and store, analyze the amount that was claimed, the total amount that was claimed that day. This GraphQL schema is defined using GraphQL entities, but this is converted to a Postgres database table, which makes it very easy to kind of define the shape of the final data. And the second file that you edit when you're building a SubQuery project is the manifest. And this is the what and the when. This is an Optimism project. And the main thing to look at here is this network piece. So this network piece is saying I'm indexing obviously from Optimism, which now is 10. It's indexing from these different RPC endpoints. And SubQuery works off the shelf of any RPC endpoints, as long as it's got enough data back in time to support the indexing. So some RPCs, for example, prune history to save on storage. But you'll be able to find a commercial RPC provider probably pretty easily. You don't have to run it yourself. And then the final thing is we do a lot of work on performance. And this is something that you guys will be keenly aware of, is indexing takes time, analyzing that data takes time, collecting that data from the chain takes time because there's a lot of it, and scanning every block is quite inefficient. So we provide some dictionaries, which are pre-computed locations of different events on the chain. So if I'm indexing just actions related to the Optimism airdrop smart contract, this dictionary down here already knows exactly on chain on those blocks where that data is. So the next part about this file is the magic happens, and you can define multiple what we call trigger points. They're really kind of trigger points, and trigger points are like certain on-chain events that I want to trigger an action from. Now, this is an Optimism example. We are indexing from the Optimism airdrop smart contract, which is this. We have imported a custom ABI for that network, so we have all the types defined nicely and safely. And then we're looking for logs on Ethereum or Optimism. And Ethereum SDK supports 3 different types of triggers. It supports block triggers, so on each and every block, do something. It supports transaction triggers on each and every transaction that matches some filter criteria, whether it's like a certain topic that tracks that the transaction has, do something. But here we have a log trigger on each and every log on the chain from this smart contract, the airdrop smart contract. that matches this filter, the claimed log, do something. And that do something is defined on the handle claim. Now, before I kind of jump into handle claim, I'll kind of show you another example. This one here is a one on Arbitrum that is indexing rewards paid out from a winner staking token or a winner staking contract. And you can see that's the smart contract code there. But this one, again, a log hand every time there is a claim batch award, we'll do something. If I want to go back to another example, one I'm recently just finished, which is one for Gnosis, and that is indexing the mints of POAPs, POAPs, which I'm sure everyone is familiar with, the tenants protocol. And this has multiple trigger points. It has a transaction trigger. So the transaction is for the mint token function. Every time a POAP is minted. And it also filter, which is for the transfer. So every time one of those POAPs is transferred between accounts. And this allows us to say who is the current owners of this NFT. And we'll come back to that one. We'll come back to this example. We're going to jump back to the original one, which is on Optimism, which is an Optimism airdrop token. And we're going to jump to the third file. So again, when I encounter a claimed log on the chain, we're going to run a handle claim function. And we define that in our third and final file. It's a mapping file. And this mapping file is defined in TypeScript. It will receive a handle claim event that you've written. And that's a claim log, which is defined or typed nice and safely from the ABIs that we imported at the start. It will log something from the console. It will check that the arguments on it, and it will create a claim. It will create a claim record that we defined at the start. It will add all the data to it. It will update. It will get a current data claim aggregation. And it does that by getting a date string. So the date string is converted from a Unix epoch to a nice string that we can use as a primary ID. It tries to get that. If it doesn't exist, it creates a new one, initializes the total claim to 0, returns that, and then we can update that total claim to new claim value. And then we can save both of those to the store. And this is a great example. So what we're doing here is all in one page, we're retrieving data, we're reading data from the store or the database. We are updating data to the database. So we're creating new data and saving it. You can also delete data from the database. And you can do bulk records and stuff to make things more performant. Inside this mapping functions, you can also, unlike the graph, the graph prevents you from using kind of any external libraries in here. We provide a lot more flexible indexing. So you can bring in a third-party API. So for example, you can go and make an external call to, if you're doing an NFT project, you can make an external call to IPFS and get the metadata payload for the NFT. If you're doing some DeFi analysis on current prices or historic prices, you can make an API call to CoinGecko, for example, to retrieve prices for that point in time as part of your indexing. You can do whatever you want in this mapping file, but it gives you the flexibility of basically, once this happens on chain, I want to process that data this way, and I want to save it in this format. And that's what SubQuery does. Another example of if we jump back to the one I showed before, which is this one on Gnosis for the POAPs, proof of the tenants protocol, we got two mapping functions, a mint token and a transfer. The graph class schema that we want to define is a bit more complex. It's got 4 tables. It's got an event, the event that POAP was minted for. It's got a token, a particular one. It's got the address, so the person that owns it. And it's got the token transfers, so the record of who has transferred that POAP between different accounts. So you can see who originally minted it, this one, mint receiver, but then you can see a current holder and a history of transfers of that POAP. And the way that that is done in our mapping files, again, is the same thing in TypeScript. We have 2 main functions. We have a handle token mint, which receives a token of mint or mint token transaction that creates or makes sure we have the event and the address, creates the new token, and then it saves it. And then we have a handle token transfer, which retrieves a token. It then asserts that the token exists, and then creates a new transfer record. So very similar in terms of what we're doing. But with this, you run this, and it's open source. So the most easiest way is to run this in Docker. You can do one command, it's a yarn dev, and that will build the project, it will generate the types, build the project. It will then create a Docker instance, and in that Docker instance, there will be a indexer, a Postgres database, and a GraphQL query endpoint. And the indexer will then go off according to this recipe or this method that you've defined in these files. It will then retrieve the data from the chain. It will process it according to the descriptions that you have, or the process you've defined here. It will then save that data into the Postgres database, and the GraphQL API endpoint will allow you to query that data from any front end or to be built. A lot of our customers will put a Metabase instance on top of it, for example. But once that data is in that Postgres database, you can do whatever you want to query or analyze that data. You might dump it into some other tool that allows you better analysis if you're looking at large amounts of data. So you're very free to do whatever you want. SubQuery is a fantastic tool from taking data on-chain into a format that you can then query and analyze and use to answer some of the questions posed on the analytics marketplace for MetricsDAO. There are a few other features I want to quickly cover around SubQuery in terms of what we do. The first thing is what you want to get started with is looking at, you want to look at the documentation that we have. So on our website, if I go to our website here, there's a whole heap of documentation. And we put a lot of effort into improving our documentation, making it very easy to follow through. So for example, for each chain we support, and we support many, we support Arbitrum, Avalanche, BNB, Cosmos, Ethereum, Flare, Near, Optimism, Polygon, and Polkadot. And for all of these different networks, you can go in and see a fantastic quick start guide that walks through kind of what I've walked you through today. That explains how things work. But there's also very dense and detailed development documentation of how to build your projects, the various different things that you might have in each of these different ecosystems. So for example, Near has, they have a block handler, a transaction handler, and on Near they call them action handlers, which is very similar to like a log on Ethereum. Cosmos, for example, they support blocks, transactions, and messages and events. It's slightly different in these different ecosystems. And so you can learn about the documentation here. Now, another thing we also support that you will find interesting, especially if you're doing some analysis on bridges, for example, you can easily, using SubQuery, build a project that indexes two different chains into the same data set. And we use this quite commonly for networks like Cosmos and Polkadot, where a wallet, for example, will want to index transactions across different chains. So that might be something of use, especially if you want to index or if you want to calculate things around bridges. You want to see the inflows and outflows on both sides of the bridge between, let's say, Polygon and Ethereum. You might want to use that. And it's very easy to do this. There's some examples in this document here around multi-chain support, which show you how you can run or create a project that indexes against on two different chains into the same data set. It's very simple. You have multiple manifests. You can share the same GraphQL schema, and you can share the same mapping files and processes. If you've ever used the graph before, which I think many of you probably have used the graph before, we make it very easy to migrate, and you would have recognized how similar SubQuery developer experience is to the graph. We do a lot of work to make that very similar and as close as possible to make it easy to migrate across. But we do a lot of work as well on performance. We're almost 2 times faster than the graph on indexing speed. We support a lot more chains than they do, especially the non-Ethereum ones. And we provide a lot more flexibility in terms of what you can do in the mapping files. You can make API calls, you can import external libraries, and many other things. And then, of course, we support that multi-chain indexing that the graph doesn't do. So there's a lot of documentation here that you might want to look at around some ideas. So that's something to keep an eye out. If one of your, we are always looking at adding support for new chains. And so if there is a request from the community around adding a support for a particular chain, we'll always be happy to provide that support. Look at that as part of our work. So please reach out if you have any requests for chain support for a particular challenge, for example. Yeah. I think that's mostly all I want to talk about today. And the main things you can do to contact us is firstly, go to our website, subquery.network, and from there you'll be able to find everything. You'll also be able to find out how to contact us, or even the home screen, actually, there's a way to contact us. You can just go book a demo and we can reach out and help you individually, and we'll be more than happy to do so. But we've built this amazing indexing tool that allows you to index data. It's very flexible, as you can clearly see. And I hope that you'll be able to use it to build some really cool dashboards and to unlock some of the questions as part of challenges on MetricsDAO. Whether it's answering a simple question like, I don't know, the block time of Cosmos networks, or the number of inflows and outflows from sexes to dexes to Uniswap, or a dashboard for tracking various metrics on Polygon. So for example, the number of X metric holders is very simple to calculate because you can just look at the number of different addresses that hold a X metric token or have received an X metric token in the past. So there's all these different examples where SubQuery is a perfect tool that can be used to source this data as part of challenges. So thank you very much for your time today. And you can always reach out to the book a demo button on our website. And you can reach out to me. I'm pretty easy to find on Telegram or on our own Discord. We have a lot of developers on our Discord. If you want to get urgent help around a question, join our Discord. There's a technical support channel, and there's about 60,000 other developers in there that will be happy to provide support and answer some questions. So thank you very much, guys.
Thank you very much, James, for the excellent presentation and for showcasing us SubQuery and how it works. So if anyone has any questions coming up later, do reach out. We added links provided, and thank you everyone for joining. Bye-bye.